Alright, so let's continue here and discover some of the other forces that are available to us in ice. So let's go ahead and let's open up the ice tree for this object here. I'm still using the same exact scene, by the way, that we were using in the previous video on forces. And this is what I had. I had this drag force connected here. So I'm going to disconnect it. I'm going to go ahead and select all three of these forces, the wind, gravity, and drag, and just hit delete on the keyboard to go ahead and get rid of them. Let's go ahead and open up the preset manager again and make sure you're back in the forces category. Let's have a look at some of these other forces. Neighboring particles force. Let's go ahead and use that one right here. Close that. Let's plug in this new force into the force 1 port of the add forces node, and let's open up its PPG and go back to our scene here. Okay, so what does this particle force do? Well, it works very similar to the coagulate force that we saw in the previous video. The main difference between the two is that unlike the coagulate force, this force doesn't take any type of drag or friction into account. So even though these particles will clump up as soon as I start to increase this attraction strength, you'll notice that something's a little bit different. The particles, if they're coming in too fast, they might actually overshoot each other or go through each other, so to speak. So they don't just clump up together like these sticky globs of glue or something like that, or mercury, or any type of liquid. Instead, they kind of just go through each other almost like they were ghosts. So they kind of just clump up, but they can actually go through each other and they won't stick together. There's no friction or drag taken into account. So that's basically the only difference between this force, the neighboring particles force, and coagulation force. So go ahead and use the one that fits the bill when you're working on your animation projects. Okay, so that's the neighboring particles force. Let's go ahead and delete it. And let's have a look at the preset manager, and we'll pull up another force called the Null controller force. Drag this one in here, and you'll notice immediately it turns red. That means that something's wrong and is not going to evaluate properly. So let's go ahead and plug the force here into force 1, and that makes both of these nodes red, and your ice tree is now broken. No, I'm just kidding with you. Actually, there's one more step that we have to do. The null controller force works with a null object, as you could have probably already guessed. So we'll go up to the primitive menu and pull ourselves up a null. And the null is in the middle of these particles. If I go back to the first frame of the animation, you can see there's the null. Let me just move it up here. And I'm going to hit enter to open up its PPG. And you'll notice here in the primary display, we can open up this drop down box and we can choose different types of icons to use for the null. What's going to happen is that this null controller force we just added allows you to repel or attract particles based on the shape of the null, and as well the scale of the null and the position of the null. So let's go ahead and sit and see how that works. First, we'll just use the regular null icon, which is just this null, and we'll leave the size alone and whatnot. Let's close the PPG and go back in here into the ice tree. With the null selected, hit F3 on the keyboard to open up this little floating explorer, and click and drag on the null name and drop it right into the ice tree. It's a fast way of dropping in a get data node here for the null. Now what we'll do is simply plug in the out name of the null, which is this little green port, and plug it into the null name of the null controller force. And you'll notice that immediately the red goes away, immediately telling us that everything should now be working the way it's supposed to. So let's open up the PPG for the null controller force, and let's go ahead and hit play to start the particle simulation. So at first you may not notice anything too impressive or too interesting, except for maybe if you caught that little detail, a couple of particles kind of flying away from the null there. Well, if we look at this PPG, we'll notice that we have a profile curve that we can use to control the effect, but we also have a parameter down here for strength, so we can increase that strength. And now you notice some of these particles are flying away from the null. They get to the center of the null and they're repelled from it. Okay, that's because the select force direction type down here is set to away from null center. We can also set it to use an input force direction, so we can choose the direction that the null is going to go ahead and repel these particles. So let's just increase the strength here, and let's do something a little bit different. Let's With the null selected, hit enter to open up its PPG, and let's pin it down for the moment. Now let's take the null icon and change its icon to say something like rings, for example. And now since the null shape changed, you can see that there's a ring in here, and if that's a little bit hard to see, I'll just go back to the first frame of the animation so you can see it. Here's the null shape. The particles will now take the actual ring shape here into account when the simulation plays. So I'll play the simulation with the null selected, and I'll switch over to the scale tool, and I'll scale the null up. And as I scale it up, you'll notice that now the particles are hitting the boundaries of those rings, and it's actually changing the way that these particles interact with the null object. So the size of the null is taken into account, as well as the shape of the null, which you can choose here on the primary display in the null PPG. We can also choose an input force direction. So we'll switch from away from null center to use input force direction. And you'll notice that when the particles enter the space of the null, now they're shot out in the y direction. How come? Because down here under force direction, we have it set to y with a value of 1. So now if I zoom out here a little bit, let me just go ahead and zoom out. You'll notice that every time the particles go into the null, they're kind of shot out. So you could use this for a lot of different things, really. You're only limited by your imagination, but it's a pretty neat way of shooting particles out once they reach a certain point. So we can actually change the direction here. So let's put 0 for y. Okay, so now it really won't have any effect. But let's go ahead and take the x and put that to, say, 1. Now you notice that when the particles reach null, boom, they're shot out to the side in the x direction. We can also type in -1 for the x, so they get shot out to the left, which is downrange in the negative x direction. We can combine these as well. We can type in 1 for x and maybe 0.25 for y, and now they're shot up to the right and a little bit above. So let's increase the y a little bit, and you can see as we change the force here for y, the particles go ahead and inherit that and take that into account when the simulation plays. So it's a pretty neat force there. Let's go ahead and take this null and delete it. Let's get rid of it. We don't need it anymore. Let's go ahead and grab the get null and the null controller force here and delete both of those. Let's go back to the preset manager and have ourselves a look at the point force. So we'll drop in the point force node here, plug it into the add forces as usual, and let's open it up. The point force attracts or repels particles based on a position in space. So it's not determined by an actual object like a null, like we just saw. Instead, you choose a position in space and you input the position here in the force center parameters. So say a position in space, maybe 5 units up in the y and maybe 3 units to the right in the x direction. Or let's go with a higher value, say 10 units in the y and 25 units in the x, which is some point over here somewhere. So now the particles are attracted to some point over here that's located at 10 in the y and 25 in the x. They're attracted to that location, and the strength parameter, of course, is going to control how attracted they are. So now they're going crazy there. They're really attracted to some point in space right about here. Okay, and when they pass the point, because they're going so fast, they'll actually make a U-turn and come back and try to set down on that point. So it's a pretty neat little trick here that you can use. This is great if you're trying to do some kind of an effect in outer space of, say, a black hole sucking debris in or something like that, or anything like that. We can also switch the force direction from attract to repel. So now particles are scared and will stay away from that spot over there. Oh no, there's a big black hole, let's stay away from it. So it's a pretty neat force that you can use, and again, it's only limited by your imagination. So feel free to experiment with it and use it for all kinds of simulations. It could be abstract work or something in outer space, or who knows what it can be. Okay, we can also choose the profile curve here, which will control the strength over the distance. So we can drop this or increase it to whatever we want. We can also come over here and enable a cutoff distance. So after a certain threshold, it won't reach. So say a distance of 1, of course, is too short, so it's not going to reach. So maybe we may need to increase this to, say, 25, or maybe even 100 here. And now you see that the particles are now starting to reach towards that point in space, which is over here somewhere. Can't really see it, it's just a point in space. but you can see the particles are being attracted to it. Okay, so let's go back to the ice tree and delete the point force, open up the preset manager. Now let's look at the last force here called the surface force. Let's drop that in here and plug this right into force 1. You'll notice it's red. Again, the surface force needs a special condition for it to work. The surface force works kind of like the null controller force we saw before. The main difference is that it works with a surface object. The geometric object can't work with a null. So we'll go to primitive. This force works with polygon mesh as well as surface objects. So we'll go to polygon mesh and create ourselves a sphere. And let's increase the subdivisions all the way up to 24 and 24 and close that PPG. Let's move this up like so. Go back to the ice tree here. What we need to do is put the sphere that we created in the ice tree. So if you remember, the quick way of doing that is selecting the actual object, in this case the sphere, hit F3 on the keyboard, and now we can do is, well, let me open up the ice tree first, of course. Now let me open up the, with F3, the floating explorer here, and drag the sphere's name into the ice tree. Okay, so here's the sphere. I'll take the value, which is this purple port here, and plug it into the surface 1 port of the surface force, and now you'll see that it works. So let's open up its PPG and see how we can affect this. Okay, the first option you'll get is the proximity method. You can choose for the particles to be attracted to the closest surface on the object, that is to say, the closest piece of surface on the object to the particles. Also, vertices or knots if you're using NURBS, as well as the closest smooth surface. So we'll stick with surface for the moment. That'll work just fine. We can also increase the strength of the attraction between the particles and the surface. We can also use a profile curve like before to control the strength over distance. And we can select if the particles are attracted down here or if they're repelled from the object. So now you'll see that they stay away. So let's go ahead and hit attract over here. Let me collapse this PPG, and I can actually interactively move this object that these particles are attracted to in my scene here. As I move it, you'll see the particles try to follow along and are really attracted to this object. Let me do something here a little bit more interesting. Let me take the set particle age limit in the ice tree there, and let me take the age limit and let me reduce it by a good amount. Go back to the first frame here, and let's increase it and increase it to about right there is pretty good, a little bit over 2. Now let's take the sphere, move it around. So you can use this actually, say for example this sphere was the was say an airplane or something in World War II, in some kind of World War II scene or game or something like that, or cinematic, and those particles could represent gunfire coming from anti-aircraft AA guns from the ground. So you can see how the tracer fire is following the target object over here, but it just can't seem to keep up. It's missing it, and then eventually, oh, it's got it, and game over. Player loses. Okay, so you can see how this this force here can be pretty interesting and could be used for a lot of things. It's really useful. Okay, so that's going to cover it for these forces in ice. In the next video, we'll just continue moving on with ice and keep covering some of the technical aspects here of ice and this introduction to ice in exercise 7.